Good day to all. I again hope all to be good. So now, gentlemen, I want us to continue with the functions, and I want us to shift focus to the domain and range of linear and quadratic functions. So now remember that the domain is a set of all allowable input values. So now these are your values of x. So now to write down your domain, you would need to make use of x like we just mentioned. So that would be the input value x would be an element of. So now element in itself just refers to a family of. So now we can then, depending on the function that we are dealing with, then pick all the values that are allowable in that function, or rather for that function. So now if you had to look at the linear function, so that would be this function over there with its equation. So now you can essentially put in any value of x. So if you choose any value of x, there will not be any mathematical mishaps. So now what we mean by that is that there won't be any errors in the calculator. There won't be any undefined and all those things. So now what you then need to then do is conclude that all x values or all input values can be used. So that would be the domain of any linear function would be x is an element of real numbers. So you can essentially put in whatever value of x you want. So that in itself will be the domain of any linear function. So now the range in itself refers to the output values. So now these are the y values. So now again, for the y, or rather for the linear function, you can essentially produce any y value provided that you are putting in whatever x value in there. So we can then also state that for the range of a linear function, the this in itself would be y is an element of real numbers as well. So this in itself would be the domain of the linear function as well as the range of the linear function. So now for the quadratic function, it becomes a bit different. So now remember that the quadratic function would either have the general formula, so that would be either this form over there or that other form. So now remember that this would be the standard form and this would be the turning point form. To find the domain of any quadratic function would be the same as that of the linear. So it means that you can put in any x value and you won't have any difficulties. So the domain of any quadratic function would be x is an element of real numbers. So now remember that x is an element of real numbers can also be written as x is an element between, not including, between negative infinity and positive infinity. So now you can either write one or the other, it does not matter. So now the range of a quadratic function is a bit different. And in this case, we will draw from the turning point itself. So now if the a is greater than 0, so that would be a positive a, it means that you are dealing with a concave up graph. So we can then have a minimum point. So this in itself is a minimum point. And the range would then be, so that's the range over there, would be y is an element. We always start from the smallest y value. So that would be including that y value. So that would be the minimum, which you can call Q, is to the maximum, which would be positive infinity, not including. So now remember that this goes to positive infinity, but it has to start from a certain minimum, which is your which would be your y value of the turning point. So now we can also do the same thing with the concave down. So that would be if the a is negative. So that's a is less than 0. So we can then say that the range would be y. So that would be y is an element between the smallest value. So the smallest value here would be the negative infinity. So that would be negative infinity is to the biggest value, which is the maximum there. So that would be the maximum, and you have to include it. So now it then means that for you to find the range, you have to know what the turning points are, or rather just the y value, or rather y coordinate of the turning point. So now this then becomes easier with the turning point form, since the Q is already stated. So now, gents, I want us to do, or rather to go through a few questions that I've prepared. So I'll just go to the next page for them. So now, given f of x equals 2x plus 3 and g of x equals x squared minus 7x plus 10. So we are given the linear function f of x as well as the quadratic function g of x. So now 1.1 wants us to determine the domain and the range of f of x. So now we know that f of x would be linear, so its domain and the range would be x is an element of real numbers, and its range would be y is an element of real numbers. So now remember that you can also just write this as x is an element between negative infinity and positive infinity, as well as y is an element between negative infinity and positive infinity. So you can choose one or the other. So now 1.2 wants us to determine the domain and the range of g of x. So I want us to just do this on the next page, since we will be required to find the turning points. So that would just be the next page. So now for us to do so, that would be g of x equals x squared minus 7x plus 10. So we firstly have to find the x coordinate of the turning point. So now this would be negative 7 divided by 2. So that just gives us a 7 divided by 2. We can then sub into the equation itself. So that would be g of 7 divided by 2. So where there is x, we would sub in 7 divided by 2. And this in itself will give us a negative 9 divided by 4. So that would be the y coordinate of the turning point. So we still yet we still need to mention the domain. So the domain would be x is an element of real numbers, like we had said. Or you could also write it as x is an element between negative infinity and positive infinity. So now the range would be, so remember that we are dealing with a concave up, so that's a positive a over there. So we know that the range would then just be y is an element, so that would be the minimum. So you would include the minimum, and you don't include the maximum, which is the infinity sign. So now, gents, that's what I wanted to share with you today. please do go over the vid so that you may be able to attempt the questions that do follow. A good day to all.